I would like to do these two examples for you in this particular video. We want to take a look at the two circles. Let's look at this first one up here. We want to know the length of RS. RS is all the way down here. Well, what's true is this chord, PR, and chord SR are equidistant from the center, 9 units from the center. They're both perpendicular to this, so they are basically the same length. They are congruent according to some of the rules that we were looking at in the notes. So since the length of this is the same as the length of this, we can say, well, the measure of P to Q is 12.5, and so we can just have to double that. This also will be 12.5, so 12.5 doubled is 25, so segment PR is 25. Since this is equidistant from the center, that one also has to be 25 units long. So RS is 25 units long. In this particular example, what's the length of LK? LK is this, it's the radius, so I'll call that R. And I have a triangle here, a right triangle here. LM is 14. I'm going to use the Pythagorean theorem on it, but I need to know the length from L to N, not this whole length. Well, since this is perpendicular to the segment going through K, this measurement is half of 14, so that's just 7. So the triangle, if we wanted to redraw it, that would be 7, that would be 3, that would be R, and it's a right triangle. So I can use the Pythagorean theorem here. 3 squared plus 7 squared would equal R squared. 3 squared is 9, 7 squared is 49, R squared then would be 58, and so the square root of 58 would be R. Let's see if that reduces. 58, boy, what does that go into? 2 goes into that. 58 divided by 2 is 29. 29 is prime. It does not reduce at all. So my answer is radical 58. If you wanted it in decimal form, we could do that. But again, decimal form is not exact. It's approximately 7.6. So radical form is usually a better way to answer that question. So the measure of R, the radius of the circle, is radical 58 units long.